Hello friends, welcome back to Byte Discovery. This is episode 5 of Learning Git Internals. In the last episode, we talked about a few commands that help us to explore the Git commit history. For example, git reflog and git log commands. In this episode, we'll explore a few commands that will help us to undo our changes to the repository. As developers, we all make mistakes, and there are some common scenarios that we all encounter. Git provides us with some effective tools that will help us to deal with these scenarios. For example, when we add wrong files to the staging area, or accidentally make multiple commits to a given branch, or discover a bug in a previous commit that we now want to fix. Some of the commands that we'll look into today's sessions are git commit with amend flag, git restore, git reset, and git revert. And we'll check a few more commands if the time permits. So let's get started. Let's consider following two scenarios. Sometimes we commit too early, leaving behind some uncommitted files, or we provide a wrong commit message that we now want to fix. Let's try to visualize them. Here we have a Git repository with file a.txt and b.txt in the working tree. We add and commit file a.txt to the repository by issuing git add and git commit command. It creates a commit hash, but then we realize that file b.txt is still not added to the commit, and this had to be part of the same commit which includes a.txt. How do we do that? The second scenario, which is quite common, is we have a file c.txt in the working tree, which we add and then commit to the repository. But only after committing to the repository, we realize that this was committed with the wrong commit message. Let's see how we can fix these two scenarios by using git commit with the amend flag. Let's start by looking into the documentation of git commit with amend flag. The documentation says that git amend flag will replace the tip of the current branch by creating a new commit. The recorded tree is prepared as usual, including the effects of -i and -o options. And the message from the original commit is used as the starting point instead of an empty message when no other message is specified from the command line via options -f, -m, and -c. The new commit has the same parents and authors as the current one. What this means is whenever we run the git commit with amend flag, this will prepare a brand new commit with same parents and author as the current commit, and it will replace the existing commit. Second is it will honor the -i and the -o options. And additionally, if -m, -f, and -c flags are not provided, then it starts the new commit by leveraging the previous commit message as the starting point. And again, this step will create a brand new commit that will replace the previous commit with the values that we provide. Let's see this in action. We will start by creating a new Git repository. Let's start by adding files 1.txt and 2.txt to the working tree. 1.txt, echo 2.txt, and to simulate the scenario 1, we'll only add commit file 1 to the commit, and then we'll see how we can add file 2.txt to the same commit. And by same commit, we do not mean the same commit hash. What we mean is both these files are the part of the same commit. So let's see this. Initial commit, git status. So at this point, we can see that file 1.txt was added and 2.txt is still untried. Let's issue git log with raw flag, and here we can see file 1.txt with the message initial commit as part of this commit hash. To make file 2.txt part of the same commit, we can do the following. At this point, file2.txt is part of the index, and this we can verify by issuing a git status command. Let's issue git commit with amend flag. And what this will do is open an editor where we can go and verify our changes. And since we are not changing the initial commit message, it will use the commit message of the previous commit as the starting point. And here we can see that the initial commit, which was the commit message in the previous commit, is the starting point. And then it says the changes to be committed are new file 1.txt and 2.txt. Once I save this file, it will create a new commit which will replace the previously existing commit and move both 1.txt and 2.txt as a part of one single commit. So let's save this. And here we can say the commit message. It created a new commit called with the same message as initial commit. And now the two files 1.txt and 2.txt are part of the same commit. Let's see what git log and git reflog commands say. Git log command says that both file 1.txt, 2.txt with this commit message are part of this hash. Git reflog, however, shows us both the commits. That means this commit is still part of the object tree and Git has not removed it from the references. We can further verify that by doing a cat file on that commit hash. And here we can see Git still has the reference to this specific commit hash, the previous one. And if we investigate the tree, it will still hold references to the previous file 1.txt. All right, now let's check the second scenario. The second scenario stated that we provided a wrong commit message, which we now want to fix. And we still want to have only one commit, which includes file 1.txt, 2.txt, and the changes in the commit message. Let's see how we can do that. To do so, we can either use the previous trick where we say git commit amend and it opens up the editor. Or there is a simpler way to do that as well. We can directly say git commit amend flag and directly pass the commit message with -m flag that we want to do. This will create a new commit message. This will create a new commit hash which will replace the previous commit, but it will still hold references to all the commits so far in the object tree. And also the reflog will also have references to all the old hashes. However, git log will be completely replaced by the most recent commit that we are going to make just now. Here, let's quickly check git reflog first. And you can see all the three commits. The first one, which did not include file2.txt. Second one that included file2.txt but had the wrong message. And the final one that had 1.txt, 2.txt with the new commit message. And if we check the git log, this now contains references to 1.txt, 2.txt, a brand new commit message as a part of the most recent commit. And here you can see it has only one single commit, which has replaced all the previous mistakes that we have done so far. All right, let's summarize what we have learned so far. We create a new Git repository and we start with file 1.txt in the working tree. We git add and we commit this file to create a new commit hash. Now we add two new files, 2.txt and 3.txt, to the working tree. We add 2.txt and we commit it with message commit1. This creates a brand new commit with this hash and the message commit1. And this adds 2.txt to the repository, and then we realize that we have not added 3.txt to the commit. In order to make 3.txt part of one single commit, which includes both 2.txt and 3.txt, we issue a command git add 3.txt. And now we open our text editor by issuing the command git commit with amend flag. This will take away our previous commit from git log and creates a brand new commit which includes both 2.txt and 3.txt as part of one single commit. Now we realize that we have provided a wrong commit message, and in order to correct the message, we again provide a git commit with amend flag, which will open our text editor, or we can shorten this by providing -m flag with our commit message directly. And this will again remove our old commit from git log and create a brand new commit which now contains 2.txt, 3.txt, and our brand new commit message as part of one single commit. Now there is one thing that we should be very careful of while making such changes using amend flag. If the commit is already pushed to remote, then others might have pulled it and made their changes on top of it. However, when you introduce your changes using amend flag, it completely removes the previous commit from the history, and on push, this might completely ruin the commit history of others. So make sure that you never amend a commit that has already been published. Instead, we can use git revert that we will talk about in the next section. Git revert preserves the commit history and makes publishing our changes much safer. Now there are some scenarios where we make a change, publish it, and then realize later that our commits were bad. For example, we might have missed to add a file to the commit, or maybe introduced a bug that breaks the production. How can we roll back this published change in a safe way? This can be done by using git revert command. Git revert is used in scenarios where we want to roll back the effects of a previous commit without modifying the commit history, by introducing a new commit at the tip of the branch, which is visible to all when we publish it. This way, all others can view both bad and the rollback commit and can reason about these changes properly. Let's see this in action. To understand git revert, let's start by creating a git repository. Let's add three files, 1.txt, 2.txt, and 3.txt as part of three different commits. And here we can see the three files 1, 2, and 3.txt have been added to the commit tree in three different commits. We can verify that by using git reflog. Git log. Let's also check git reflog, which says initially the head was at this commit, then it moved on to commit 2 with this commit SHA, and finally to commit 3 with this commit hash. Now let's say commit 3 was the one which introduced the bug in production. How do we revert it? This can be reverted by using git revert either the head, or if we know the commit SHA, we can use that. And once we do this, this will open up an editor which will prompt us to provide a new commit message, and the action will be to delete the file which was introduced in the commit 3. And let's check the status of the working tree. At this point in time, file 3.txt has been completely removed. But let's say this was not a bad commit and we made a mistake by reverting commit 3. We can go a step further and undo this revert again by saying git revert head, which says now it's reverting the reverted commit 3. And now a file will actually be added to the commit tree. Let's proceed with this. And now let's check the status of working tree. And you can see file 3.txt, which was removed in the previous revert operation, has now been reverted back. All right. Now let's say we finally identified that it was file 2.txt which introduced the bug in our production, we can go ahead and find the commit hash of commit 2, which is this, and say git revert this commit hash. It opens up the editor where we can provide our commit message, but the action will be deleted 2.txt. Let's proceed with this and check our working tree. And you can see that the effects of commit 2 have now been reverted. Let's check the git log and go through all the operations that has happened so far. So we started with adding 3 files, 1, 2, and 3.txt in 3 different commits. We then reverted the effects of commit 3 by providing git revert, which deleted file 3.txt. Then we realized it was a bad revert, and we undid the effects of our revert by doing a git revert again, which in turn added the removed file. And finally, we realized that 2.txt was the one which caused bug in production, and we did a git revert on that commit hash, which undid our actions. Let's also quickly check git ref log, and it tells us we started with 3 different commits. Then we performed a revert action on commit 3. Then we performed another revert action on the revert of commit 3. And finally, we realized commit 2 was the one which had bug, and we reverted that change. It is important to understand that during this whole operation, we never modified the commit history and only rolled forward with the new commits to fix our bugs. All the object references created are still in the object tree, and status of git log and git ref log are aligned with the actual progress of the commit history. Now, there is one edge case with git revert that is important to note. To demonstrate that, let's add a new file called 4.txt in a new commit. So we have created a new commit 4.0 where we have added a new file 4.txt. All right, let's create a new file 5.txt and additionally modify the file 4.txt. Now let's create a commit 4.1 which adds these two files in the commit history. All right. At this point, we added file 4.txt in commit 4.0 and then modified it in commit 4.1. Let's see what will happen if we revert the commit 4.0 which added the file 4.txt. And then let's do git revert that specific commit. And this revert will throw error. The reason is that after commit 4.0 which added file 4.txt, there was another commit 4.1 that further modified the 4.txt. So just reverting the commit 4.0 in itself is insufficient. In order to fix that, we have to first abort our current commit. And then we first revert commit 4.1 and then 4.0 to undo our changes. Here, this will revert commit 4.1. And then we can proceed ahead with reverting commit 4.0. And let's check the git ref log. So we added a file 4.txt in 4.0, then we modified the file in commit 4.1, and then we reverted commit 4.1 first, and then reverted the commit 4.0 to completely remove the changes introduced by 4.txt. Let's summarize Git revert. We start by creating a Git repository with 3 files in the working tree, 1.txt, 2.txt, and 3.txt. We add file 1.txt to the commit tree, commit it, and we get a new hash. We do the same for commit 2 and commit 3. And at this point, we realize that commit 1 might be the one which introduced bug in our code. So we can undo the effects of that commit by providing git revert with the commit hash of commit 1. And this will take away all the changes that were introduced by commit 1 and create a new commit. If we further want to remove the effects of commit 2, we can issue a command git revert with commit hash of commit number 2, and this will take away all the changes introduced in by 2.txt. So git revert is one of the safest option to undo your changes. It updates the git history but does not rewrite it. So it can be safely applied to commits that are already published. Now let's talk about the git restore command. Unlike other commands that we have discussed today, git restore does not change commit history. Instead, it is used to restore the files in the index or the working tree from their counterparts in commit and the staging area. It is primarily used to undo the effect of git add or discard local changes in the working tree. It has following optional flags. The first one is source, which is head or SHA commit if we know it. Next one is options, which are again optional, and it could be either the work tree or the staged with -w or -s flag. If -s is provided, then updates are taken from the head. Otherwise, it's taken from the index. And finally, we have the path, which is the list of the file that should be restored. Let's visualize this. Let's assume that we have a Git repository with file a.txt in working tree, staging, and the repository. And all of these have completely different changes. In order to restore the working tree from index, we can issue a command git restore a.txt without any flag. And by default, it always restores the working tree from the index or the staging area. The second option that we have is to restore the index or the staging area from the commit. And that we can do by providing an option called -s with the file name. And here git restore -s a.txt will restore the staging area from the head. We can also restore the working area by providing a -w flag. Or if we want to restore both staging and the working area, we can provide both -w and -s flags. Let's see this in action. In order to understand the working of git restore, let's start by creating a Git repository. On the top pane here, we are tracking the differences between the head and the staging area. And on the bottom pane, we are tracking the differences between the working tree and head. Right now, these error out because we don't have any files on Git. Let's start by creating a file 1.txt. And let's add and commit it to the repository. And now you can see there are no differences between the file 1.txt in working tree, staging, and the commit. Let's make an update to 1.txt. And now you can see there are differences between the head and the working tree. All right, let's do a git status, and we have one untracked file. Let's add it to the git repository, to the index area. On the right hand side, you can see the differences between staging and head are exactly same as the difference between working tree and the head. Let's now make one more change. And now you can see differences between staging and head are different from the differences between working tree and the head. The working tree has this additional text YYYY, which is not present in the uh, staging area. And let's see how we can start using git restore command to sync these changes. The first thing that we discussed was to move the changes from the index or the staging area to the working tree. For that, we can just say git restore one.txt. And now you can see the differences between head and staging versus head and working tree are exactly the same. All the changes that were present in the staging area have now been moved and synced to the working tree, and working tree has lost all its changes. Let's go again and make the changes to one.txt. Now let's try to pull in the changes from head to the staging area. -s one.txt, and now in the upper pane we should see no differences. All right, again, if we want to also sync these changes to the working area, we can provide a -w flag. And at this point in time, both working tree and the staging area are synced with the changes from the head. Let's redo this activity one more time and provide both -w and -s flag. Git add, and then make the change one more time. And here you can see we have some untracked changes in one.txt, we have some tracked changes in one.txt, and we have a version in the head. And now let's try to sync both tracked and untracked changes with the version in the head. So for that, we can say git restore -w -s one.txt. And you can see the changes in the head are synced with the changes in the staging area as well as in the working tree. I hope this made sense. It's important to understand that git restore is a destructive operation. It completely throws away any local changes in the working tree, and we should use git restore to work with the working tree only when we are absolutely sure that we don't want those unsaved local changes. Now let's discuss the final command for today's session, which is git reset. Git reset takes in two parameters. First is commit hash and second is the mode. It has several modes, but for today's session, we'll only cover soft, mixed, and hard modes. Git reset acts like a time machine that can be used to move the head back to one of the previous commits, effectively deleting any commits that came after it. To do a reset, we provide an SHA indicating which commit hash to move to, whereas mode defines if the files in the working tree, index, or repository will be affected. For example, if we provide the following command, it will move the head to the previous commit, and it will delete any commits that came after that particular commit. Additionally, the mode will determine if the changes should be made in the working tree, index, or both. Let's see this in action. To demonstrate this, we will start by creating a new Git repository. We will then add a file one.txt, add and commit it. All right, let's create a new file 2.txt. Let's add this file with commit message commit 2. All right, let's see how git reset in soft mode works. Let's do a git log. It says file 1.txt was added as a first commit and file 2.txt was added in the second commit. Let's issue a command git reset soft head tilde 1. This will move the head to commit 1. Let's check the status. Right, reset in soft mode has moved the head to commit 1, but the index still reflects the state right before the commit 2.0. Additionally, there are no changes made to the working tree. That means soft mode just moves the head but does not make any changes to the index or the working tree. Now, since the file is already in the staging area, let's commit it with a new commit message. Let's do a git log, which confirms that file 2.txt has been added to the commit. Now let's do a reset in mix mode. And let's check the status. Let's also check the git log. As before, reset in mix mode has moved the head to commit 1, but it has also cleaned up the state of the staging area. However, the working tree still shows the state just before git add for the commit 2.1. With this behavior, we can infer that mix mode also moves the head, cleans up the index, but does not make any changes to the working tree. Now let's check how the hard reset works. We will start by adding the file to index and providing a new commit message. And here we can see that there is a new commit for file 2.txt with message commit 2.2. Now that the file has been committed, let's see how the hard reset behaves. And here you can see the head has moved to the previous commit. However, when we try and check the file in the working directory, we do not have any 2.txt. This means that hard reset has completely discarded all our changes after commit 1, and the state of the working tree and the index reflects the state right after the commit 1. We can also infer from this that any local changes are completely lost and will not be able to recover them. Let's summarize how git reset works. Let's assume that we have a Git repository with two commits, C1 and C2. Their corresponding states in index and working tree are marked as W1, W2, and S1, S2 respectively. Reset in soft mode will move the head to commit C1, while index and working tree will be in the state S1 and S2 and W2. Reset in mix mode will again move the head to C1, but this time the state of the index will be cleaned up while the working tree will reflect state W2. And finally, the hard mode will also move the head to C1, but the state of working tree and index will be cleaned up, discarding any local changes. At this point, the state of repository reflects the state right after commit C1. I hope this clarifies how git reset works. Great. In this session, we have explored some common git commands that can be used to undo our changes and fix any mistakes. We have also covered a few scenarios where we can utilize these commands and make correction with confidence. In the next session, we'll go through a list of few more use cases and apply our knowledge to recover from common errors that we make while using Git. See you guys in the next video.